So previously हमने लास्ट क्लास में फेस पोर्ट्रेट स्टार्ट किया था, so we are continuing with that, and we'll now discuss the construction of face portraits. Face portraits. Portraits. So as far as the face portraits are concerned, we can directly simulate them using computer programming. Fine. So, but we still need to have an understanding about how to be able to sketch a face portrait, even if it is a rough sketch using uh, manually. Fine. तो इसमें दो टेक्निक्स हैं आपके पास. One is the analytical method and second one is the graphical method. Uh, so as far as the analytical method goes, it's basically simply using differential equations जो आपके पास available है. Using those equations, you will be able to plot x1 versus x2. Fine. And if it's not possible to basically find out the differential equation of a system, we can use different graphical methods for constructing the phase plane portraits. And उसमें जो सबसे important method है, that's basically the method of isoclines जो हम later on पढ़ लेंगे. Fine. So you have two methods. You have the analytical method, and the result is दोनों में आपको एक ग्राफ, एक फेज पोर्ट्रेट, you have to draw a face portrait, and one will be using the equations and second will directly involve the use of graphical tools available to us. Fine. So in this there is the method of isoclines that we'll be taking up. There are a number of methods. Isoclines is the most important of them, and we'll be taking up the method of isoclines later on. So as far as the analytical method goes, again you have two ways of obtaining the phase portrait. You are basically trying to plot x1t versus x2t. Fine. Uh, and as I've been telling you that the phase portrait method, it is applicable to second order differential equations. That does not mean it's not applicable to first order or third order. You can extend the phase portrait to third order systems. You can use it also for generating the phase portrait of a first order system, but that basically involves a lot of complexity, and it's generally speaking used for second order differential equations for plotting the for plotting x1 versus x2. First method, analytical method, you will calculate the value of x1t, you will calculate the value of x2t. Once you have the values of x1t and x2t, you can basically, for each and every time, you can basically say what will be the value of x1, what will be the value of x2t, and therefore you will be able to obtain the value of x1 versus x2. जैसे हमने लास्ट टाइम वाली एग्जाम्पल में किया था, we took an example of a mass spring system. हमने x1t निकाला, हमने x2t निकाला. Obviously, because the equation was x1 square plus x2 square equal to x0 square, we directly were able to say that this is a system, this is a plot of a circle. But even then, if we would have taken for each and every value of time t, we would have said x1 is this, x2 is this. अगर हमने x1 versus x2 plot किया होता, that would have come out to be a circle eventually. But the second method that we use in analytical methods, and generally speaking we use it, we eliminate t. In second method, we basically eliminate t. That means once we have actually we have equations of x1, we have x2, we have actually dx1 by dt, we have dx2 by dt. Fine. what we do is we divide dx2 by dt divided by dx1 by dt. That means uh, x1, that's basically we have x1 dot and x2 dot. What we do is we divide x2 dot by x1 dot or x1 dot by x2 dot. We eventually obtain dx2 by dx1. So this basically represents now a single differential equation. You had two differential equations, dx1 by dt and dx2 by dt. They were very basically being differentiated with respect to time t. We eliminate the need of time t in here by dividing the two differential equations and obtaining a single differential equation, that's dx2 by dx1. After you have obtained basically this equation that basically also gives you the slope of a system, you integrate this. Obviously, after integration, you will have a certain constant term. That constant term will have to be evaluated using the initial values of the system. And once you integrate this, you will be able to get an equation that will represent x2 and x1. And then once you have that equation, that basically is a relationship between x2 and x1. After this, this will basically give you a relation between x1 and x2. Once you have this relationship, between x1 and x2, we'll be able to plot we'll be able to sketch the relation between x1 and x2. Fine. So there are two methods to construct a phase portrait. One is the analytical method, second one is the graphical method. Analytical method basically use the mathematical tools. आपके पास जो available differential equation है to plot x1 versus x2. The graphical methods, it will be basically for some systems obtaining a differential equation for a non-linear system is a bit difficult. So we directly use the graphical tools using the method of isoclines extra to plot the phase portrait of such systems. Then talking about analytical systems, again you have two methods. One method is obtain the value of x1, obtain the value of x2 for each and value of time t, plot x1 versus obtain the values of x1 and x2, and then you can sketch x1 versus x2. In the second method, instead of using two differential equations, you can combine the two differential equations by dividing them. You obtain a single differential equation, dx2 by dx1 or dx1 by dx2, एक ही बात है. Once you obtain this, integrate this equation, you will get a relationship between x1 and x2 that you can plot in the x1 x2 plane. Fine. So taking an example of this, let's start with the example that we took last time. X double dot x equal to 0, where m and k were basically equal to 1. x double dot plus x equal to 0. फाइन. सो हमने बेसिकली इसमें क्या किया था, हमने इसको लैपलास से किया था. We had obtained the values of x1t, we had obtained the values of x2t, x1 हमें x naught cos t आया था, कुछ something like this, x naught sin t. So squaring and adding, you obtained x1 plus x1 square plus x2 square is equal to x naught square. You were able to say this is basically a plot of a circle. So this was method 1. What you do is you obtain the values of x1t, you obtain the value of x2t, and once you have done that, plot each and every value of x1 and x2 versus time. Then you can basically sketch x1 versus x2. अगर हम इसको सेकेंड मेथड से करेंगे, फॉर दैट say x equal to x1. Last time हमने ये नहीं किया था. I do not suggest this to you because if you will approach using this method and then obtain the solutions of x1t and x2t, you will not actually be getting x naught cos t and x naught sin t, you will be getting something else.
सर सर लास्ट टाइम जब हमने इस वाले इक्वेशन को सॉल्व किया था ना यूजिंग लैप्लास,
हाँ
सर तब हमने वो गलत किया था
क्या
क्योंकि सर वहां पे सर लास्ट टाइम जब हमने इस वाले इक्वेशन को सॉल्व किया था ना यूजिंग लैप्लास ट्रांसफॉर्मेशन,
हम्म
सर वो हमने गलत किया था तब, आंसर आया ही नहीं तब। हाँ मतलब मैंने जब वो खुद से ट्राई किया सर, वो निकला ही नहीं क्योंकि सर मेरे ख्याल से कि इसको ना सर इनिशियल कंडीशन मतलब गिवन होनी चाहिए तभी जाके वो इक्वेशन तब सॉल्व
no,
होगा।
we do not need to find out the initial conditions, वो just a general example थी, we'll come to that, अगर आपको लगता है उसमें कुछ गड़बड़ थी I will see to that, but ऐसे कुछ गड़बड़ नहीं थी, fine, I will see that,
ओके
but you're talking about after the class, fine. For now,
ओके
let's use method number 2 to plot the phase portrait of this system. Method number 2 में हम क्या करते हैं, basically we need to find out dx2 divided by dx1 integrated and find out this relationship between x1 and x2. So for that, let's say x is x1 and x dot is x2. That means basically x1 dot is equal to x2, x1 dot is equal to x2, x2 dot will be equal to minus x1. Fine. Directly from this equation, 1 x1 dot will be equal to x2. ठीक है, इसमें x1 dot in the equation कहीं पे है नहीं, so x1 dot is x2, x2 dot is minus x1. Now what we have to do is we have to divide x2 dot divided by x1 dot. Therefore x2 dot divided by x1 dot will be equal to minus x1 divided by x2, which gives us x2 into this is actually dx2 here, not x2 dot, dx2 divided by dx1, x2 into dx2 is equal to minus x1 dx1. Fine. So once you cross multiply, you will get x2 into dx2 is minus x1 dx1. So integrating both sides, x2 dx2 का integral is equal to integral x1 dx1 minus, which implies integral of x2 dx2 will be x2 square integral of x1 will be minus x1 square by 2 plus a constant c. Fine. So x2 square plus x1 square divided by 2 अगर हम c के साथ ही एलिमिनेट कर लेंगे is equal to c. Now what will be the value of c? For that you have to basically substitute x1 and x, you have to substitute the initial conditions. So you can say c will be equal to x1 naught square plus x2 naught square. Substituting the value of initial conditions, you can find out the value of constant c. C will be equal to x1 naught square plus x2 naught square. In any so c is basically a constant here. Now you can, even if which implies x2 square plus x1 square is basically dependent upon the matrix x naught square. You can see x2 square plus x1 square is equal to x naught square. So you are still getting an equation of a circle. You can plot this. You can now plot x1 versus x2. You will see basically x1 versus x2 will be an equation of a circle. Origin point last time मैंने आपको नहीं बताया था. What will be the origin point? कहाँ से basically start होगा? Origin of the plot is basically the points x1 naught x2 naught. You will start with the very first points जहाँ पे जो भी आपके values होंगे x1 naught और x2 naught के, accordingly you will start plotting this graph. ठीक है, x1 naught say for example is 3, x2 naught is 4, so accordingly आपका जो ये c होगा that will be 3 square plus 4 square, 9 plus 16 whatever 25. So you can basically, it will be a scalar quantity in short, so it will represent a radius of a circle, and the plot will start, it will still be a circle only. अब ये plot कहाँ पे start होगा, आप कहाँ से start करोगे draw करना, that will depend upon whatever is the value of x1 naught and x2 naught. ठीक है, so we have done this equation, we have done this using two methods. One method is finding out first the value of x1t, finding out the value of x2t for each and every value of time t, find out what is x1t, x2t, and then you can basically plot x1 versus x2. A fairly simple example थी. और the second method that's used, जब आपके पास x1 dx1 by dt होगा, dx2 by dt होगा, divide the two, you will get dx2 by dx1. You are having a single differential equation integrated. Since we do not know the limits of integration, they will be associated with this a constant term c. ये जो आप c calculate कर सकते हो by substituting the values of x1 and x2 equal to the initial conditions of the system. So in this case, c will be equal to x1 naught square plus x2 naught square. So depending on whatever is the value of x naught, whether it's 3 plus 4 square, whatever, 0 plus 0 square, equilibrium point जो भी होगा, आपका plot का origin वो होगा, but it will eventually be a circle in this case. Let's take another example. Let's take an example of a satellite control system. इसका जो ब्लॉक डायग्राम है, we basically have a satellite control system, and what we are going to be assuming here is that we'll be taking the linearized form of this block diagram. Normally the satellite control system is a non-linear control, it will have non-linear control dynamics. ठीक है, अब जब हम एनालिटिकल मेथड पढ़ रहे हैं, we can solve the non-linear control systems, non-linear equations using analytical techniques, but it becomes very difficult for us. So most often what we do is non-linear जो आपकी equations होंगी, पहले हमको linearize करते हैं, उसके बाद piecewise linearize करते हैं, उसके बाद basically हम system को plot करते हैं. So for this particular system जो आपका satellite control system है, इसमें जो equation of motion है, that is governed by this equation, j d square theta by dt square equal to torque tau. Fine. We are basically neglecting the values of any damping or any friction in the system that may be basically present in the space. ठीक है, so एक frictionless environment होगा. So you have the equation of motion for that system will be simply j d square theta by dt square is equal to tau. This is basically j theta double dot is equal to tau. So what you can do is you can now say say theta is equal to x1, therefore theta dot will be equal to x2 will be equal to x1 dot. That means from this equation x2 dot will be equal to tau divided by j. Fine. So you have x1 dot equal to x2 and you have x2 dot equal to tau divided by j. Therefore x1 dot is x2, x2 dot is tau divided by j. Therefore, that means dx1 by dt is x2, dx2 by dt is tau by j, dx2 divided by dx1 will be equal to tau divided by j divided by x2, right? Which implies x2 times dx2 is equal to tau by j times dx1, integrating both sides. These are so far these are fairly simple integrations. x2 dx2 becomes x2 square by 2 equal to, assuming tau is constant, this becomes tau by j times x1 plus a constant of integral, that is c. Or in other words, we can also say x1 is equal to j x1 square divided by tau, 2 tau rather, 2 tau, प्लस माइनस लिखें एक ही बात है प्लस say for example this is c1, this becomes c on this side, जो positive है. So therefore x1 is equal to j divided by 2 tau times x.
सर j टाइम्स x2 स्क्वायर आएगा.
क्या
सर यही j into x2 स्क्वायर अपने x1 लिखा था.
So j divided by 2 tau x2 square plus c. C is a constant of integration. And how we can determine c? We can determine it x1 naught minus j by 2 tau times x2 naught square. So substituting the initial conditions of x1 and x2, we can basically determine what will be the value of c. So basically we have an equation that is this, and we have to basically see ये किस चीज की equation है. x1 is equal to j by 2 tau times x2 square plus c. So if c is 0, that means x1 is equal to j divided by 2 tau x2 square. So x1 or x2 square basically means we do not need to plot it exactly. A rough sketch will do. This is x2, this is x1. For all positive and negative values of x2, x1 will be basically positive. It's basically an equation of a parabola given like this. Fine. So j का कुछ वैल्यू होगा, इट्स मोमेंट ऑफ इनर्शिया, इसका कुछ पॉजिटिव फिक्स्ड वैल्यू होगा. अब टाउ इट कैन आइदर बी पॉजिटिव और इट कैन बी नेगेटिव. दिस इज द टॉर्क ऑन द सिस्टम. सो it can either have a clockwise rotation or anti-clockwise rotation. Accordingly tau भी positive होगा या negative होगा. So if assuming tau is greater than 0 in the first instance, x1 versus x2 will basically be a parabola. Also assuming that c is equal to 0 in the first case. Fine. So this also means c is equal to 0. Now if c is not 0, c is any positive number, that means this parabola will be shifted by whatever is the value of c. C will be a scalar quantity. It will have a fixed definite value. So if this is c is equal to 2, c is equal to 3, c is equal to 4, whatever is the value of c, this parabola will get shifted towards the right. Or if c is negative, this parabola will get shifted towards the left. Fine. So what? 1, tau greater than 0, we have x1 versus x2 will basically be a parabola. For all positive and negative values of x2, x1 will always be a positive quantity. ठीक है, assuming for c equal to 0. Accordingly फिर c का क्या वैल्यू होगा, ये जो आपका पैराबोला होगा, it will either be shifted towards the right or it will be shifted towards the left. Fine. हमें exact values फेस पोर्ट्रेट से लेने की ज़रूरत नहीं होती है. We only need a sketch of the phase portraits to determine whether a system is stable or not. We'll be seeing to that later on. Accordingly, if tau will be लेस देन ज़ीरो, अगर आपका टाउ नेगेटिव है तब आपका जो आपकी इक्वेशन है दैट्स x1 इज इक्वल टू जे बाई 2 टाउ x2 square. Tau is negative, that means this whole quantity becomes negative. For c equal to 0, it will be something like this. फिर अकॉर्डिंगली अब आपका c पॉजिटिव होगा या नेगेटिव होगा, आपका ये जो parabola, it will be shifted towards the right or towards the left. So this is the phase portrait of your system. J d square theta by dt square equal to torque tau. This is for a satellite control system जहाँ पे हम इक्वेशन ऑफ मोशन को प्लॉट कर रहे हैं. And it's basically in a space, we can basically assume it's a frictionless environment. You have no viscous friction, you have no friction, you have no spring constant here, anything like that. So J d2 square by dt square is equal to tau. And now whether it's a clockwise rotation or an anti-clockwise rotation, accordingly आपका जो फेस पोर्ट्रेट होगा या तो लेफ्ट टू राइट होगा या तो राइट टू लेफ्ट इंक्लाइंड होगा. So this is how you basically use analytical methods to plot the phase portrait of certain systems. Let's assume another system. J theta double dot plus B theta dot is equal to tau. So we have now another system जहाँ पे आपका विस्कस फ्रिक्शन B भी है और आपका inertia भी है. For such systems, again we can basically assume that tau is constant and it's not a varying quantity. So we can determine whether we can basically plot the phase portrait of the system. So again, assume theta equal to x1 and x2 equal to x1 dot is equal to theta dot. Therefore, x2 dot is equal to tau minus b x2 divided by j. Tau minus bx2 divided by j. Fine. We have x1 dot equal to x2 and you have x1 dot equal to x2 and you have x1 dot equal to tau minus bx2 divided by j. So you have to basically solve for dx2 divided by dx1. x2 dot minus bx2 divided by j. Fine. So this is your equations x1 dot and x2 dot. You need to find out now dx2 2 divided by dx1. So can you find out the values of dx2 divided by dx1 and integrate it?